Hi everyone, welcome back to my channel. Let's continue from where we left off in the previous session. Today we will be moving ahead with the next part of the topic, so let's get started. So now let's learn the chapter triangles. In this chapter we have to learn a little bit more theories and concepts are there to understand. So first one, let us learn about the similar figures. Similar figures means what? For example, if I'm drawing a triangle like this and another triangle like this, but they both are of this thing that this angle is equal to this angle, and if this angle is equal to this angle and this angle equal to this angle. Okay, so let me name this triangle A, B, C, D, E, F. In this condition, if angle A equal to angle D, angle B equal to angle E, angle C equal to angle F, also AB by DE equal to BC divided by EF, which is equal to AC divided by FD. If this condition also satisfies, then we can tell that these two triangles are similar. So the similar triangles means what? Any figure, let it be a triangle, let it be any polygon. Two polygons are said to be similar to each other if their corresponding angles are equal and length of their corresponding sides are proportional. So that is the condition for any similar polygon. So in a triangle, what? Triangles are special type of polygons, right? So in this case of triangle, if either of these two conditions are given, like the given condition satisfies, then we can tell that what? These two triangles are also similar. Okay, that is the criteria for all two triangles to be similar. So now let's do the theorem 6.1. The theorem is also known as BPT theorem as well as the Thales theorem. Okay, what does this theorem states? The theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, other two sides are divided in the same ratio. Okay, so here that means what? If here BC is the line, right? If I am drawing a line called DE, which is parallel to what? Which is parallel to BC. This BC and DE are parallel lines here, right? When I draw this DE parallel to BC, what did it do? It cut the triangle ABC at the points D and E such a way that it cut AB into AD and DB and AC into AE and EC, right? Therefore, as per the theorem, it says that AD by DB should be equal to AE by EC. That is what the theorem states. So now, what we have to do, therefore, here in this triangle, in order to prove this theorem, we have to do some constructions. What we have to do, we have to draw EG perpendicular to AD as well as from D we have to draw a line DF perpendicular to AE. Clear? Along with that, you will have to join E and B and D and C. Clear? Now, whenever we write the theorem, first thing we have to write the statement. Then we have to write the given part. Then what we have to write? We have to write if there any construction or anything is there. A second part we have to write to prove. Okay, to prove. What do you have to prove here? To prove AD divided by DB should be equal to AE by EC. Clear? Then, if there is any construction in this theorem, we have to write the construction as the third part. In the construction part, what we have to write? We have to write EG, draw EG perpendicular to AD. Okay. Draw EG perpendicular to AD and DF perpendicular to AE. Clear? Along with that, what you have to do? You will have to join BE and DC. Okay. Then we have to write the proof. In proof, what all thing we have to do? Take the triangle ADE. In triangle ADE and in triangle BDE, in triangle ADE and in triangle BDE, what all things we can write? We have to write its area. Okay, first let me write in triangle ADE and triangle BDE. Now to avoid confusion, I can draw the triangle here once again. Okay, that means I'm drawing the triangle like this. Then we have to draw that line. Okay, then we are telling about this line. Okay, then one more thing we have to draw. We have to draw that perpendicular part to the side. So we are having A, B, E, D, G. This much is okay for this one. In triangle ADE, what is area of triangle ADE? Area of triangle ADE equal to, we know that if you want to find the area of a triangle, what we have to do? We have to take half into base into altitude. Here, I have to take half into, if I am taking my base as DE, then my altitude is, here I am taking EG as my altitude and naming it as equation 1. And area of triangle, what? Area of triangle, here we have to represent it by small a. Area is written by, okay. Area of triangle BDE. How to find the area of triangle BDE here? That means, which part? This triangle, okay. If I want to find the area of this triangle also, which is the altitude here for this one, if I'm taking BD as my base, half into, what? Base means BD to this base. If I want to do take the perpendicular height, means this is our perpendicular height, right? That is going to be the, so into EG. And for this one, I'm going to give equation number 2. Now I have to find area of triangle ADE divided by area of triangle BDE. What is it? Which is equal to half into DE into EG divided by half into BD into EG. So what we can do here? We can cancel this one and this one as well as this one and this one. So what will be left over? Area of triangle ADE divided by area of triangle BDE equal to DE divided by BD. For this one, I will give the equation number 3. Okay. Now what I have to do? Similarly, I have to take in triangle ADE and triangle CDE. So, which is the triangle? Let me draw the triangle here. Okay. This is the triangle called, then ABC, and this is that parallel line. So, A, B, C, D, E. Here I need to draw which part? I need to draw only these two lines, okay? This one and to this side also I have to draw that altitude, right? So here this is the 90 degree and this part I will mention it as F. Therefore, if I want to find area of triangle ADE, what is the area of the triangle ADE here? Area of triangle ADE equal to Using DF as the altitude, I can write it as half into, my base is going to be AE into DF. This one I will give as equation number 4. Okay, then again I want to find area of triangle CDE. If I want to find the area of this triangle, CDE means this part, right? If I want to find the area of this part, what I have to do? I have to take half into, my base is going to be EC into, but the perpendicular height is what? This is the perpendicular height, that is DF, right? And this one I'm going to name the equation number 5. On comparing, if I'm dividing 4 divided by 5, what I will get? Area of triangle ADE divided by area of triangle CDE equal to half into AE into DF divided by half into EC into DF, right? Here again what I can do? I can cancel this one, this and this. So what will be left over? That is area of triangle ADE divided by area of triangle CDE is going to be AE divided by EC. Clear? And this one I will give as equation number 6. Okay. Now if you are looking here, now I got AE by here also. If you are checking here, you can see that area of triangle ADE by area of triangle BDE equal to DE by BD. Okay. And here you got area of triangle ADE by area of triangle CD is equal to AE by EC. This much you got. Now one thing we have to write. Now what do you have to write here? Now we can write that if you are looking at the denominator part, you can see that these two triangles, right? This one and this one, right? They are actually equal. We can write that using our theorem that we have learned in 9th grade. Okay. Which theorem? If we are having, think that this is a common base and we are having two triangles in the same common base. Okay. Like this. What we are going to get? The triangle formed between triangles on the same base and between the same parallels. Here you can see that this is a parallel line, right? We have learned what? There DE is parallel to BC. This line was parallel to what? This line. So, two triangles between the same base and the same parallels will be equal in area. Therefore, here I can write what? This area will be equal to which area? This triangle, because this triangle is having two parallel sides common and two parallel sides as well as the common base. And here also you can see the nest triangle, right? Which is sharing this common base, and these two triangles are between the same parallels, right? Now we can tell that these two triangles, the triangle 1 and this triangle 2, both are what? Are having the same area. Using the theorem, we can write here what? Now, area of triangle BDE is going to equal to what? Area of triangle CDE. Then you will have to write the theorem there. Like, what is the theorem says? Because triangles on the same base and between the same parallels what they will do? Same parallel line are equal in area. Clear? Thus, we can write these two triangles are having equal in area. Therefore, our equations, we got here two equations, right? Our third equation as well as what is our third equation says? This is our third equation. Area of triangle ADE by area of triangle BDE equal to DE by BD. And here we will have next one, area of triangle ADE by area of triangle CDE equal to AE by EC. These two equations you have to take from equation 3 and 6. What can I write? Area of triangle ADE divided by area of triangle BDE equal to how much? It is equal to area of triangle ADE divided by area of triangle CDE. Okay. Therefore, we can tell what? Therefore, we can tell that from 3 and 4 we can tell what? We can tell this one also. I will give the equation number 7. Okay. Hence, I can write what? From equation 3, 6 and 7, I can write AD divided by DB. It is going to equal to what? AE divided by EC. Then we have to write hence proved. Clear? That is what all thing we will have to write here. We will have to write. First, we have to take our this triangle. In that, we have to do these all constructions. After, we have to take the triangle ADE and triangle BDE. There, we will have to prove, find the areas of these two triangles. Okay. Similarly, what we have to take? We have to take the next two triangles, which is ADE and triangle EDC. There also we will have to find the area of the triangle AED and area of triangle EDC. There you will be using the altitude DF. Then after comparing them both, then you will have to use this theorem. Triangles on the same base and between the same parallel line, they will be equal in area. Using the theorem, our denominators we can make it same in the equation number 3 and equation number 6. That means area of triangle CDE will be equal to area of triangle BDE. Since our denominator, already the numerators are same in the left hand side, and now we have proved that denominators in the left hand side is also equal. Thus, if the left hand sides are equal, that means what? Automatically the right hand sides also will become equal. That is what is in equation 3, the right hand side is DE by BD, and in equation 6, our right hand side is what? In equation 6, our right hand side is AE by EC. Then we can write that AD by DB equal to AE by EC. Clear? Now, let's do the next question. Question number 3. In the figure, if LM is parallel to CB and LN parallel to CD, we have to prove that AM by AB equal to AN by AD. So, whenever you are writing a question, means for writing the answer part, we have to first write the given. What is given here? Given in triangle ABC, if I am taking just the triangle ABC, you can see there what? LM is parallel to CB. Then in triangle ADC, what is given? In the triangle ADC, LN is parallel to CD, right? So, if I am taking the first triangle, then first we wrote the given item. Then what we have to write? To prove. What we have to prove? To prove that AM by AB equal to AN divided by AD. This is what we have to prove here. After writing the to prove, we have to now since here no construction is there, we have to write proof then. Okay, so first we have to take what? In triangle ABC. Okay, let me draw the figure here. This is the triangle. In the triangle ABC, what it is given? This is A, this is C, and this is B, this is M, and this is L. It is given that LM is parallel to BC. Since LM parallel to BC, what we can write? AL. Therefore, AL by LC equal to AM by MB. I can also write, that is what? AL by AC equal to AM divided by AB. Right? Using which theorem we are writing this one? Using BPT, basic proportionality theorem. Okay. Similarly, we can take the triangle, next triangle, which is a next triangle in, and this one I will give it as the equation number 1. In triangle ADC, what I can write? Okay, first let me draw the figure. This is A, this is N, this is L, this is D, and this is C. Here again given NL NL is parallel to CD. Therefore, what we can write? Therefore, AN by ND equal to AL by LC. Also, that means what? That is, I can write AN divided by AD equal to AL divided by AC. This one I will give the equation number 2. This is by using BPT. Clear? From 1 and 2, what can I write? From 1 and 2, I can write that AM, 1 says what? AM by AB equal to AL by AC, and 2 says that AL by AC equal to AN divided by AD, right? Now if you're looking here, you can see what? The right hand side is same. Therefore, automatically what? Therefore, we can write, if the right hand sides are same, therefore automatically the left hand side also will become, LHS also will become same. That is, AM by AB will become equal to what? AN by AD. This is what they are asking us to prove, right? Therefore, we can write, hence proved. Clear?